Hi, everybody. This is Mr. Foley, and welcome to 4.2. There is no 4.1, but we are doing 4.2. 4.1 got cut, so we are in the right spot. Please make sure you have your periodic table ready because we are going to look at it a bunch. So first of all, periodic table can indicate the charge of the atoms when they form ions. So let's make this a little bit bigger so we can see it. On the first column, everything in this column is +1. Everything in this column is +2. Everything in this column is +3. This one is 0. Oops, I almost put plus in. That's not right. So it goes 1, 2, 3 up, and then it goes -3, -2, -1, 0. Okay. Positive ions, remember, lose electrons. So if you're +2, you lose 2 electrons. And negative ions gain electrons. -3 means gain 3 electrons. Never change protons. All right, so here we go. There are parts of the periodic table we're going to look at first. So this blue part right here, this is called the S block. Okay, you can see this part right here, the yellow part here, this is D. This part right here, the green part, is P. Notice how this little guy over here goes with the S's, and over here we're with the F's. So we need to know those regions for what we're going to do next. We talked a little bit about electrons and where they go before. Now we're going to do it with a little bit more intensity. Okay? Electrons are arranged oddly in clouds. We kind of showed them as rings before. That's not right. They're really in clouds, and these clouds have weird descriptors. The number of electrons equals the number of protons unless it clearly states it's an ion. Same thing as last chapter. There are 4 types of clouds. S, which is the first 2 columns, and helium, and it holds 2 electrons. 2 columns means it holds 2 electrons. P is dumbbell shaped. Boron through neon and below. So what that means is here's boron, here's neon. So this group right here, here are my P orbitals. Okay. D, the shape is called complex. That means you don't need to know where it is, or you don't need to know what the shape is. They're in the crossbar. So I'm going to highlight yellow on yellow here so you can see it. Yellow, there's my crossbar. There's my D orbitals. Okay. And then the F is also a complex shape, and that's the bottom 2 rows, and it holds 14 electrons. So if you count the columns on your periodic table, you'll be able to see how this has 1, 2 columns. That's why there's 2 in the S's. The P, whoop, whoop, that holds 6. The D, whoop, whoop, that's 10. You can count them if you want to. I'm sure you're good at counting. I'm good at counting too. Okay. An electron configuration has 3 parts. The coefficient, hey, just like math class, that's the number in front of the letter. It tells us the energy level. In this case, it's going to be the rho. It tells us the rho on the periodic table. Okay, we'll get to that a little bit more in a second. And then I'm going to skip this for just a second. The block, this is where, so this letter is the block. Remember, S, this is where it tells us where it is on the periodic table. There's S, P, D, and F. The superscript, that tells us which column it's going to be in. Oh man, I don't think I understand any of this, so let's just do some of them, okay? So I'm going to start with lithium. Lithium has 3 electrons. I have to account for all of those 3 electrons, and I'm going to fill from the top left on through. Whoosh. There's 1, 2, and there's the third one. Lithium is going to start off on the first row. See the 1? It's going to start in the S block, and there's hydrogen and helium, and there's 2 of them. That means 2 electrons. Now when I look at lithium, the next one, the third one, now I'm on the second row. I'm still in the S block, but I only have 1 of them in there, right? I'm going to stop right here, 2s1. 2 electrons plus 1 electron equals 3 electrons, and that's how many lithium has. Okay, that kind of makes sense. Let's do some more. Phosphorus is right here. Phosphorus has 15 electrons. And it's going to look a lot like lithium that we just did. So I'm going to do the first 2 electrons right here. First row, S block, 2 of them. 1, 2, 2. First row, first row. Okay. The next 2 electrons come in this chunk right here, which are on the second row, still in the S block, and there's 1, 2 of them. That takes care of 4 electrons. The next chunk that's going to come through here is right here. I'm still on the second row. I'm now in the P block. See how this is the P block. And I have 1, 2, 3, 4, 5, 6. 2p6. Okay. If I add them up, I have 2 plus 2 is 4, plus 6 is 10. I'm going to 15, which is my atomic number. Now, number 11 and 12 are right here. That's the third row. That is the S block. And I have 1, 2. My next chunk is going to be 13, 14, and 15 right here. Still on the third row. Now we're in the P block, and we've got 3. And then that adds up to 2, 4, 10, 12, 15, which equals 15. Woof, what are we doing here? Okay, so what we're doing is we are just counting electrons and saying where these electrons are. So when we look at them, remember how when it was simple and we thought, okay, they'd be in these little rings? It's kind of like that, only the electrons are more complicated than rings. But this is how we describe where they are, okay? All right. Titanium, 22. I am titanium. I'm going to point out again, number 22 is going to encompass 15, so we should see this copied again. But let's look and see if we can see the pattern forming. It should look the same. First 2 electrons. First row, S block, 2. Next 2 electrons, lithium and beryllium. Second row, S block, 2. Next block, 5 through 10. Second row, coefficient is 2. The block that I'm in is in the P block. And there's 1, 2, 3, 4, 5, 6. Now, I was talking about these blocks. How did I get those blocks again? Remember up here, we've got S, we've got P, we've got D, we got F. Okay? And honestly, we're not going to do anything with the F, just between you, me, and the walls here. Okay. So we're at titanium, we're at 2p6, we're boom. We've got to do 11 and 12. 11 and 12 would be third row, S block, 2. Now we got 13 through 18. Still the third row, P block, 6. Whew. Still trying to get to 22. 19 and 20. Remember, I care about this wall right here of ending the S block. 19 and 20. Fourth row, S block, 2. And now D is a dog. Okay, so up here, we talked about D. Okay, so when I talked about the coefficient, remember this is your coefficient. Titanium, atomic number 22, ends in 3D2. It should be on the fourth row, but it is a 3. Okay, so I'm going to tell you a little story. I had a kid in my class who got all D's. And in Indiana, when I was in 3rd grade, if you got all D's, they held you back. So the kid's name was Matt Adcock. Matt Adcock was supposed to be in 4th grade with me, but he ended up in 3rd grade because he got held back once. Okay? So the D is held back once. D is held back. The 4 becomes a 3. So I'm looking at titanium here. I'm going to erase this so we can see it. We are now at this part. It's on the 4th row, but because it's D, it's not going to be in the 4th row. It's on the 3rd row. 3D2. Okay, so normally when we think of the nucleus and we keep adding shells, what happens is the D block goes, I'm going to go out of order and I'm going to sneak right in here. And that's what happens. Okay, so the D would be off by that. Just the coefficient is off for the D block. Okay. The F block does the same thing. except for the F block is off by 2. The F block, woof, the F block is off by a lot here, okay? If you look, the F block is 58, so we do 55, 56, 57, then we go to 58. Whoa, okay? So it should be on the 6th block, but really it's on the 4F and 5F. And to be honest with you, I really think you're better off just remembering that's 4F and 5F, okay? All right. These get to be a nightmare, right? Imagine if I said, all right, now we're going to do polonium, 84, shut up. I'm going to hit skip, 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 and play this at 2.75 speed and be done. Well, we're going to be shorter than that. There's a short form, which is also known as core notation, also known as noble gas notation, okay? They're all the same. The important part here is that we're going to focus on these parts here. These are our noble gases, okay? And they fill up a row. And really what we care about in chemistry is not all of the electrons. We only care about the outermost electrons. So this is going to emphasize the outermost electrons. So what we're going to do is going to write the preceding noble gas and then start from there. Aluminum is right here. The preceding noble gas for aluminum would be neon. So I'm going to write neon in brackets. That's 10. 11 and 12, third row, S block, 2. 13, third row, P block, 1. That's it. That's shorter. That's better. That's my dog barking. Xenon. Ooh, doggies, 54. I don't want to do all those. That's a noble gas, but we're going to do the preceding noble gas. So the noble gas preceding xenon is going to be krypton. So in brackets, I'm going to throw krypton. And then I'm going to do 55 and 56, 6th row, S block, 2. Notice, remember that this weird 57 thing? 57 and then 58 goes down to there. 57 is D blocks off, 5D. 1. 58 is all the way 58 through 71. Man, I'm trying to get through. Oh, poop. I did the wrong one. That gets me for not being able to see right. You heard me go poop. We're doing krypton. There's 36, 37, and 38. I told you you wouldn't have to do F block. 37 and 38, I can count. 36, 37, 38. That's 5S2. 39 through 48, remember D block is off by 1. Instead of being 5D, it's 4D, and there's 10 of them. And then the P block, I'm going to fill that one out. I'm going to go back to 5. 5P6. All right? Yay. All right. So some naming issues. I just want to remind you that CO is carbon and oxygen. Big C, little o is cobalt. All right. Orbital diagrams. Pretty nice because we give you the orbitals already. Boxes. Each box represents places that electrons, which we show as arrows, can be. Boxes hold at most 2 electrons, 2 arrows. So I can't fit a third one in here. That'd be terrible. Electrons fill boxes in a subshell by having the same direction and even spreading. A subshell would be 3p. See how all of these, there's 3 boxes in there? Everybody gets 1 before anybody gets 2. So let's do some. Chlorine. Chlorine is right here, number 17. Easy way to do chlorine. Chlorine has 17 electrons. I'm just going to start filling them in. 1, 2, 3, 4. Now, once I get to 2p, I have to spread them out first. There's 4, 5, 6, 7, 8, 9, 10. Remember, max is 2. 11, 12, 13, 14, 15, 16, 17. Remember, chlorine had 17 electrons. There's 17. And I have 1 single electron. Okay? Notice how I did up, 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 down, down, down. The other way to do chlorine is if I write out chlorine's electron configuration. Yeah, I just learned how to do electron configurations. Let me do that. I'll work on my skills. Chlorine is 17. 1s2. 2s2. 2p6. 3p2. 3p5. Now that I've got that, I know my electrons. 1s, up, down, I have 2. 2s has 2, up, down. 2p has 6, 1, 2, 3, 4, 5, 6. And that took care of those 6. 3p2, up, down. 3p5. Remember, p's got to spread them out. 1, 2, 3, 4, 5. And there we have it. All right. Carbon. Carbon's much shorter, only has 6. I'll write the electron configuration for carbon. 1s2, 2s2, whoops, 2p2. 1s2, 2s2. This is wrong. No, that's wrong. You can't put them both in there. Remember, you have to spread them out for p's and d's. 1, 2. That's it. Okay. Single electrons matter because that tells you how many bonds they got to form. All right. Valence electrons are your outer s and p electrons. That means you're looking at the biggest coefficients. So chlorine's biggest coefficients are 3. 2 plus 5 is 7. Carbon's biggest coefficient is 2. 2 plus 2 is 4. The number of valence electrons tells you the maximum number of bonds it can form. Single electrons in an orbital diagram will always form bonds. Not sometimes, always. Just like you will always be glad that we're done with this video. This one was rough, so we will take it slow and we will review, and you will love it, love it, love it. Thank you so much for coming in today and watching the video. Remember, without you, there is no us. Toodles.